In this problem, we have three vectors. Those vectors are already broken up into their x and their y components. We want to find the magnitude of the resultant vector, meaning if we add all of these vectors together, what is that result? So because these are already broken up into x and y components, then we want to find the total x component, or Rx. What is the result of adding all of these x components together? So if we do 4.4 plus 2.1 plus 4.4, that turns out to be 11. And we want to do the same thing with the y components, the result of adding all of these y components together. So 5.1 plus 3.3 plus 5.9 is 14.3. So if we know now Rx and Ry, if I draw a sketch here, all right, so if Rx is a positive 11, Ry is a positive 14.3, and again, not drawing these to scale. You could if you used a ruler. But then R is what we want to solve for. R is the resultant if we added all these components together. And so we have now a right triangle. And so R, the hypotenuse, is going to equal Rx squared plus Ry squared, and take the square root of that. Right? It's very much doing Pythagorean theorem. A squared plus b squared equals c squared. Right? We're using R instead of c. Okay? R is the hypotenuse. So if we plug in our values, 11 squared plus 14.3 squared, and we want to take the square root of that. All right, so I'm going to do 11 squared plus 14.3 squared. I'm going to take the square root of that. Answer, I get a magnitude of 18.0. We didn't have any units here. This could have been meters, could have been meters per second, any kind of vector units here. Could have been newtons for a force. Okay? And we just wanted the magnitude. We didn't want the direction. So 18.